The definition. So a neutralization, you can see what I'm writing, right?
Yeah.
All right, a neutralization is the reaction between a strong acid and a strong base. All right, to produce water and salt. All right, and the one that we worked with in the lab, though, it was the very first of the titrations that we started with. Not the stuff that we finished with was more advanced and is going to fall outside this definition a little. But what you guys need to know, so this is a classic neutralization here where we react hydrochloric acid with sodium hydroxide, and then we're going to produce water. And in this case, we produce table salt, like that, right?
Okay.
Remember that the strong acids, I'm just going to diagram them quickly here. Hydrochloric acid, hydrobromic, hydro, iotic, sulfuric, nitric, and perchloric. Whoops, that should be bigger. These are your 6 strong acids. So you need to make sure to have those committed to memory. And then there's 5 strong bases. So all of them follow the pattern of the reaction that we just did over here. All right, and the strong bases are NaOH, KOH, barium hydroxide, strontium hydroxide, and calcium hydroxide. That's just to remind you with what the deal is. All right, now you can see, so when we talk about neutralization, why are these called neutralization reactions? All right, well, you have the definition here, and you're looking at an equation. And where the word neutral comes from that characterizes this reaction, the a strong acid plus a strong base to make water and a salt, is the fact that when you're done with the reaction, right, there are no reactants left, right? You remember when you did this in the lab, your collection flask turned green?
Yeah.
And it was just salt water. So this is called neutralization because the pH of water is 7. And this is neutral. So at the end of the reaction, there's no HCl left. There's no sodium hydroxide, right? If you apply some of the other things we've learned, if you look at the coefficients, they're 1 to 1. So once the hydrochloric acid is gone, so is the NaOH. And the only thing that you have now left in the collection flask is this stuff right here, plus a little bit of indicator. And water is pH 7, which is neutral. So that's why this is called a neutralization. And any of these strong acids, when they're combined with a strong base, are going to do the same thing. They're going to produce water and salt, so that the only thing in the collection flask that has any ability to be acidic or basic is water, and literally water is in the middle of that, right? It's neutral. It's neither basic nor acidic. Did that answer your question?
Yes.
Are you certain?
Yes.
Okay, is there anything else that I need to leave the whiteboard up for?
Not that I have anything.